Youssef intends to buy a car. He wishes to estimate the mean fuel efficiency in miles per gallon of all cars available at this time. Youssef selects a random sample of 10 cars and looks up their fuel efficiencies on the internet. The results are shown below. A. Youssef will estimate the mean fuel efficiency of all cars by calculating the mean for his sample. Calculate the sample mean and record your answer. So in order to calculate the sample mean, we are going to add up all of those values and then divide by 10 because there are 10 values in our list. It should look like this. And then you would divide by 10, but a lot of people are doing this in their calculator, and what's happening is it's only dividing the 27 by 10. So to avoid that mistake, you can either hit equals and then divide that answer by 10, or you can put parentheses around it so it calculates the sum first and then divide by 10. And you are going to calculate that on your own. You have all the resources at your fingertips to finish that problem. B. In practice, you only take one sample to estimate the population characteristic. However, if Youssef were to take another sample of 10 cars from the population, would he get the exact same values for the sample mean? So just like we did with the exercise problem in class at the gym, if we took another sample, or if our peers took another sample, they should be similar, but they will not be exactly the same. It's very unlikely that you will get exactly the same answers. C. What if he were to take many random samples of 10? Would all of the sample means be the same? Just like in class, we had over 20 students take the sample mean, and I don't think a single one of them came out exactly the same. So he would get different values for the sample mean. Again, he would get different values for the sample mean. D says, using this example, explain what sampling variability means. Sampling variability is about the spread or the changes in values that you would get. So the fact that the sample mean changes or varies from one sample to another is sampling variability. Two, think about the mean number of siblings, brothers and sisters, for all students at your school. What do you think the approximate value of the mean number of siblings for the population of all students at your school? So for 2A, we're talking about the average or the mean number of siblings someone has. It wouldn't be likely that you would get a number like 20 siblings, but there could be, on average, 3 siblings in a family, or they could have 2. So choose a number that would be reasonable based on our community of how many siblings you think most people would have. I'm going to go with 2. B. How could you find a better estimate of this population mean? If we were to look at our entire school and figure out how many people or how many siblings each person has, that would be a population mean. And we want to estimate that. But we don't want to have to ask every single person in our school. We want a quick way to figure out an estimate. What would we have to do? We would need to take a sample of students at our school. But you also want to make sure that your sample is random so that you're not just choosing friends or choosing older kids, but that you get a sample of your entire school. So take a sample that is random. C, suppose that you have now selected a random sample of students from your school. You have asked all of the students in the sample how many siblings they have. How would you calculate the mean? To calculate the mean, you add up your data values and divide by how many there are. In this case, your data values are based on the siblings. So you add the number of siblings and the amount of data values is the amount of people you ask. So you're adding all the siblings, and then you are going to divide by how many people you sampled. D, if you had taken a different sample, would the sample mean have taken the same value? Think back to problem 1. If they took another sample of 10 cars, would it come out exactly the same? We said no. So if we're going to take a different sample from our school, we wouldn't expect them to come out the same here either. But again, they should be similar. E. There are many different samples of students that you could have selected. These samples produce many different sample means, just like we did in class. What is the phrase used for this concept? When we talk about where those points are, and we talk about all the different answers that you guys collected, what did we call that? They also discussed this in question 1D. So this is called sampling variability. And finally, F. Does sampling variability that you gave apply only to sample means? So one thing that you might say here is it wouldn't apply to a population mean, because if you asked the entire population and took the mean, you should get the same answer as if you asked that same group of people again. It doesn't apply to population means, but there are other versions of finding center, for example, median and mode, and so it could apply to that. Sampling variability would apply to any sample statistic. Don't forget your name on your paper.